cost of electricity. And I looked around and, okay, so 32 cents a meter cubed is what we were paying not too long ago, like 2007 for natural gas. So that brings you down to that blue line. And this 55 cents a meter cubed, that was the highest priced natural gas I could find in Canada at the time. And you can see that, yeah, we can actually have a net or a negative return on investment here if electricity was low and natural gas was high. We produced about 19,000 kilowatt hours total in electricity, and about 52,000 or 51,000 kilowatt hours of heat for the building. Total emissions for the system were about 17 tons of CO2. If he had used the existing furnaces and bought power from Sask Power, it would have been about 26 tons of CO2. So it's a pretty significant reduction in CO2 for this one facility. So the benefits to the utilities such as Sask Power and Sask Energy is that over 90% of the Saskatchewan buildings are connected to the natural gas network. Mico CHP is another venue for Sask Energy customers to produce heating and their own power. Right now, Sask Energy is locked in their price for the next year for natural gas, so we're going to see continued low prices on natural gas. Sask Power, they experience their peak electrical demand in winter months. Mico CHP systems would be running during this time and potentially reducing the provincial demand once you have many units installed. Because we had been monitoring this building for a little bit over a year, we were able to compare kind of apples to apples. So here's a typical day in January 2010, typical day in January 2011 after when we had the CHP system installed. And so this is a manufacturing facility, so they're kind of closed through the night. You know, they start coming into work and coffee break and lunch and coffee break and home. So what we can see here is that there is a reduction in demand, about 2.5 to 3.5 kilowatts on the building itself, which isn't great, but when you install 1,000, 10,000, 100,000 of these systems, now we're talking real demand reductions to Sask Power. Widespread adoption is really going to help reduce that electrical demand and also reduce these line losses in the system. We currently lose 5 to 10% of our electrical generation just in line losses transporting it. Using the power on site is really going to help with that. We have natural gas all the way up to L'Orange. You know, it's really it's a good fit for Saskatchewan. Some of the key accomplishments is that we were able to, the required functionality and feasibility has been demonstrated. The system worked. It worked in black start. We were able to supply power to the grid and to the building independently. The heating system worked. It was able to cover a large portion of the heating demand in the building. We were able to get 4,500 hours worth of runtime out of the system. We think we could even get more. But more importantly, we learned some very valuable maintenance cycle information. The system itself had a 22-liter oil sump on it, and that's to really get your 1 year worth of operation before you had to do a major oil change. But we did every 1,000 hours. We came in and we looked at everything. We took oil analysis, we took coolant analysis, we looked at spark plugs, any of the valves, that kind of thing. And really looked at the optimal sizing of the system. We could probably go with a little bit larger system in this building, but we might reduce our run hours, but you'd be able to produce more power. And really that control logic that we're going to face in any building. You got to be able to implement it with its current system without doing a really complicated control system that is going to fail or people aren't going to understand and just want to click it off. We successfully demonstrated a prototype unit and identified those regulatory issues that people are going to experience when they go to adopt this technology. We worked really close with the code officials, engaged them early, worked with them throughout the design, had their input, and in the end it made for a better project. Right now, SRC, we plan to continue to develop our small commercial CHP. Because units have come on board into the Canadian market now, we're looking at demonstrating a Marathon Eco Power unit. Unit originally out of Germany, and they're produced actually just in the US. So we're going to pilot one of these CHP plants in Saskatoon. We have a we're right now doing the site-specific design. This system has a 300,000 BTU boiler, so we're going to be able to tie in with a hydronic system. We think it's going to really reduce the installation costs and get us an idea of how this system is going to work in a high temperature application. And we're also going to install it inside the building so that we can see what kind of regulatory issues are involved with that. Sound might be an issue, as well as, you know, is there going to be any smells from the system? Is there going to be any exhaust leaks? How do these engines work inside of the building? This system is meant for interior installation, so we're hoping there won't be any. We also plan to pilot other scales of this technology. We'd really like to try the suite out of systems that are available in the market, all the way down from the small residential systems up to the very large systems. We want to determine what the greenhouse gas emissions. Every scale is going to have its different barriers. You know, it might be cost, it might be implementation, but we want to really see what kind of benefits we can get out of it, so that when those barriers on cost are overcome, we're ready to install these systems in Saskatchewan. And also look at some of these niche markets where there might be a potential to run this system 100% all year. I read an article in Japan. They're using massive amounts of sewage produced by cities. And so they're producing biogas off these sewage treatment plants and running the CHP plant. And they're using the heat to process the sewage, which produces more biogas. And they're producing like 300,000 to 400,000 kilowatt hours of electricity at zero cost, because they need the biogas. They need to do something with biogas, and they're using the heat to improve their processes. So I think there's likely some niche markets out there that we can apply these systems on. I'd like to acknowledge a lot of the people who were involved in this project. Rob Craddock at Inland Metal Manufacturing, he was a great host. We had a press event down there. He was more than helpful. He shut down the shop, let all his workers sweep it up and set out chairs. It was great. Jim LaRock and Gary Webster from Advanced Engine Technologies, they did a great job developing the system and providing us technical support along the way. As well as my colleagues in Regina, Sean Wedewer, Grant McVicker, and Ray Seaver. They were great. They were on site lots, you know, working with the system and really giving people tours and working through it. Also have to thank all of our funders. We had 3 major funders in this project: CanMet, Enercan, and Sask Energy and Sask Power. Advanced Engine Technology supplied the CHP. We had lots of in-kind support from Selkirk and Inland Metal in terms of ductwork and exhaust pipe. And also our local contractors did a bang-up professional job. DNA Applied Controls helped with the control system. Global Lead did all the electrical work for us, and RE Mechanical did a great job installing all the pipe. So with that, I'd thank you for your time, and happy to answer any questions.
How loud are these? How loud is the equipment?
This system here, we didn't actually do a sound measurement on because it was installed outside.
Mm-hmm.
The Marathon unit we're installing is rated at 50 dB. So it's about the same level as a conversation.
Mm-hmm.
A little quieter than me. But that is a big thing too. We don't, you know, and that's why the Stirling engines are really looked at in the residential market, is because sound is more the issue there.
Right.
In the commercial market, you're going to tend to have them installed inside the mechanical room where you have all kinds of stuff making noise anyway.
Mm-hmm. Mm-hmm.
You mentioned you're doing a pilot project with the Marathon system in Saskatoon. Where,
yeah.
Or can you tell me where?
Yeah, actually, I guess we just signed the agreement, so it's all official now. It's Cypress Sales partnership. Yeah, so we'll actually be installing it in there. Well, we plan to, I guess I should say. It hasn't been installed yet. But we plan to install it in their showroom. So it's going to be a great visibility site. You're going to see directly, because he's already got his boiler set up in there as kind of a showpiece. So we'll be able to tie in the Marathon system to his boiler, and you'll be able to see firsthand how that's installed and see it run.
It was interesting at the very end when you talked about the using biogas for sewage treatment. And so I was thinking about that before you got started, sort of other fuel sources aside from natural gas.
Yeah, there's been some development in the Stirling engine side on using wood pellets and kind of gasifying those. They're running into some technical issues in terms of fouling on the engine itself, just because you have a little bit of soot. We're sticking with natural gas right now. It's clean lots of different fuels that could be used. In the end, it's just an engine. So if you can run it through an engine, it'll work.
So we run like a landfill or methane?
I think there's potential for something like that if you had a steady supply. You don't want your supply to dip and drop, so if you had a steady